Alright, here we go. So here are the practice problems I gave you. Start with the first one. The third one really made me nervous, but we're going to try it. I'm going to be... I haven't done these yet, so I think we can do it though. Alright, I definitely look at this this first one, and I'm asked to find y prime, and I see a function to a function. Okay, so I'm thinking, well, if I want to find the derivative, I need to get that function that's an exponent. I need to get this one in yellow. I need to get that down. So I'll take the natural log of both sides. Natural log of both sides. So I got y, and I can move that over. This is the natural log of, let's see, cosine 9x. And that is raised to the, well, I should have parentheses here. Cosine 9x is raised to the natural log of x squared. You're like, wow, there certainly is a lot of natural logs there. But I think we can do it. Just let's keep track of what we're doing. This first step, I've just said, let's take the natural log of both sides. Now, I'm going to move this function out front. Right? So the natural log of x squared times the natural log of the cosine of 9x, and that's equal to the natural log of y. Alright, now I got some, now I can do some calculus. Right? The derivative of the left-hand side is 1 over, with respect to x, so I'll write that. So now we're going to do the derivative, so d dx of the left must equal d dx of the right. So the derivative of the left is 1 over y times y prime. That y prime is showing up because we're taking the derivative with respect to x, and the inner function is y. Okay, the right-hand side, I'm looking at that and I'm thinking I'm going to have to go product rule. I got the green times the blue. And then when I get to the derivative of each of those, I think I've got some chain rule built in there. So let's go green. So just the green function is x, natural log of x squared. The derivative of the blue function, I'm going to go outside in. So 1 over cosine 9x. Check. Next inner function is cosine. Negative sine is its derivative. Next inner function is 9x. 9 is its derivative. Okay, so now I got the first function times the derivative of the second plus the derivative of the first function. So you got 1 over x squared times 2x. Okay, times the second function left alone. That's natural log cosine 9x. Let's get out the highlighter. Okay, so the natural log of x squared, it shows up there, and its derivative shows up there. The natural log of the cosine of 9x, well, its derivative is there, and then the function by itself is there. The only thing left to do, I mean, I certainly could simplify, and then I got to multiply both sides by y. So if I multiply both sides by y, the left side turns into y prime. So I'll have y multiplied by the entire right side. So let's clean it up. Natural log of x squared. Let's see, 9. Well, I'm going to write this as negative 9 sine 9x over cosine 9x. So what you see here that I put in a box, I simplified that. Plus, let's see, this right here, you got 2x over x squared, so 2x over x times x. That's just 2 over x. So plus 2 over x times the natural log of the cosine of 9x And then our last step is just to substitute y in. So y right there will get replaced with this whole thing. So go back to the start. You know what y is in terms of x. So we end up with y prime equals, let's see, cosine 9x, cosine of 9x raised to the natural log of x squared. Okay, so that's y, which, that's right there. And then multiplied by, so I'll put my parentheses in, natural log x squared times negative 9. This could be cleaned up more, but I'm not going to right now. It's not really the point of this exercise. Negative 9 sine 9x over cosine 9x plus 2 natural log of the cosine of 9x all over x. Okay. Now I put those two fractions into one. Like, if you multiplied those two fractions, so say what I've got in highlighted in purple, if you multiplied those two fractions, you just go top times top, bottom times bottom. So I just wrote it as one fraction. I certainly could have on the other one too. But there we go. There's y prime. That was just the first problem. Okay, let's do the second one now. This one doesn't look... Oh, this one's not as bad. We're good. Okay. Alright, so this is one of those where you got a number. Y is a number raised to a function. This one, if you do enough of these, number raised to a function, you'll find a nice slick formula, but I try to memorize as little of stuff as possible. So I've got a procedure that will get me through function raised to a function. So instead of memorizing another formula, I just I go through the procedure again. And sure, it takes me a little longer, I guess, but I don't know. I guess I don't have the capacity to memorize all that. So, anyways, I'm gonna go natural log both sides. So natural log left, natural log right. 5e to the x squared y. I'm gonna move that exponent. Okay, move that out front. So I got natural log y equals e to the x squared times natural log of 5. Take the derivative of both sides. So d dx, d dx, natural log of y. Now I'm taking the derivative of both sides because that's what the problem asked for. They said, what is y prime? And I should have said, I could have just as well said, y prime equals question mark, or I could have said dy dx equals question mark. They mean the same thing. So I'm searching for the derivative of y with respect to x. I'm searching for y prime. Alright, so the left side turns into 1 over y prime. The right side, I've got, that's just a number. So the derivative of a number times a function is going to be the number times the derivative of the function. So I really just need that piece. So the outer one is e to the x, so the outer e to the x squared. The inner is x squared, its derivative is 2x. Multiply both sides by y, and you get y prime equals 2x natural log 5 e to the x squared times y. And y was 5 raised to the power of e to the x squared. So, going backwards here, Yeah, you could simplify it a little bit. That's not the focus right now. There you go. There's y prime. There's your slope finder. So you would use that equation to find the slope of any of the tangent lines along y. Okay, one more. It's the last one. It was the... I look back and I wonder why I wrote it now. But let's try it. Okay. Oh, so I'm looking for y prime. I've got this whole function to a function, so I'm going to take the natural log of both sides. So I'll try to use different colors here to keep track of what we're doing. Okay, raised to the natural log of x squared. Okay. So, we got that exponent. Okay, we can move it out front. So we're going to do that. So this exponent you're going to see in blue, I can move out front just because of properties of logarithms. So that's going to come out front. No calculus has been done yet. Natural log of x squared. And the left side is the natural log of y. No calculus has been done yet, but now I can. Right? Let's take the derivative of the left and the derivative of the right. So the derivative of the natural log of y, the left side, is my 1 over y times y prime. The right side, let's see, I'm going to go product rule on this. Right, I've got the yellow function multiplied by the green function. The natural log of 6x. That should be fun. So, product rule. Right? The yellow times the derivative of the green plus the derivative of the yellow times the green. So yellow times the derivative of the green. Alright. Outside in, I'm going to go. So the first natural log, I got a 1 over the whole guts there, natural log of 6x. The next inner, so is natural log, so 1 over 6x. The next inner is 6x. Okay, so we better make some more room. Okay, so I got the yellow so far. There's the yellow times the derivative of the green. Now I got to go plus the derivative of the yellow times the green. So here's my green, natural log of the natural log of 6x. Here is my derivative of the yellow. I'm going to clean this up. I'm going to multiply both sides by y. Let's get y prime equals y multiplied by that entire right side. Okay, so these are all like fractions. I notice right here that's equivalent to just 1 over x. So if I those fractions I was talking about here, just go across the top, we'll multiply them, and across the bottom we'll multiply them. But make sure, you know, I replaced 1 over 6x times 6 with 1 over x. So we got the natural log of x squared over x times the natural log of 6x plus, okay, no, these are all fractions. Let's see, 2x over x squared is just 2 over x. So I got 2 over x, I can do it in 2 steps, sorry, 2 over x times the natural log of 6x. So that's just over 1. So I'm going to go ahead and combine these two fractions, top times top, bottom times bottom. Y prime equals, let's see, what was y? I want to fill this y in. Let's see, y was this mess. Okay. Okay, so that takes the place of y, multiplied by the natural log of x squared over x natural log of 6x plus 2 natural log of the natural log of 6x all over x. Sweet, we did it. Good job. And that's it. Those are your three practice problems there with logarithmic differentiation.